Sick of needing a jump start, a hip swing, or a cheeky assist from the table to get that tail swinging? Well, stop thrashing around and jump for joy because we have the product for you. Introducing My Own Tail, the tail that moves when you do. Let's hear from the creator of My Own Tail. My Own Tail is, at its heart, a work of biomimetics. Most animal muscles use series actuation and elasticity rather than the rotational motion one sees out of most electric motors. I had considered series elastic actuators for this application, however it seemed unnecessarily complicated and expensive for something like this. What seemed more appropriate was turning rotational motion into contraction using a wire along a flexible core, and a pulley system which would pull this wire and have it cause a curving motion at the top of the tail along the length of the tail. There are quite a few works out there that make use of this principle, and I found one I thought would work very well. In terms of material, there was really no question that the first version, at least, should be made out of plastic, as it has made the iteration process simply a matter of changing something I thought needed alteration and 3D printing a new part. I thought my first tail used mostly parts that were in the original design I found online, printed on a hand-tuned printer bot. The electronics were implemented on an Arduino Uno, and the muscle sensors were MYOWare's basic product. This worked very well, though several things jumped out as needing improvement. First was that the tail itself was not wearable, lacking any attachment points for a belt. It also had a lot of electronics that were outside of the tail itself and would tend to shift and fall off surfaces during demos. Also, there was no need for something as large as an Uno for this application. It was simply much more processing power, much more size than was needed for effectively two sensors and a motor. Finally, the wire slipped out of the pulley system quite a bit, decreasing the amount that the tail itself would bend, the flexible plastic part. So you would ideally want to be able to pull and have the tail go like this. And as you can see, even now, even with this improved one, that the wire does very easily escape the this pulley system, even with these springs trying to provide a bit of extra tension. The wheel itself was also not optimized for attachment points for the wire. This is the second version. The original one was rounded here, and I had to slice it off a bit. Here, I printed it out flat, so I could just drill a hole and thread it, and put a screw here, glue in, and have the wires where that needed to be. And so in the second version, as I mentioned, I added a belt loop opening here, and made the wheels deeper to try to hold the wire better. It still, as you can see, does not work brilliantly, and we'll be getting onto that in a moment. I also decreased the main wheel size, as you can see in the picture, and in the demo you'll be seeing on the day, and in some of the videos, that the main wheel was about this big. It fit the whole area, which is why this had to be this size. I shrank it to possibly even shrink the whole thing. That did not work out as I had hoped, as actually this wearable demo is in fact not even necessarily all that functional. As you can see, I can turn the wheel all the way, and it doesn't. Well, wouldn't do anything that. You can see it really does not. Even if I have it all the way good here, it doesn't really do very well. The original one, the main wheel does not turn even all the way. See, it works okay in some directions. The main wheel doesn't turn all the way to bend it, so I thought that maybe by shrinking it, I could have the servo turn more to have better resolution. I have forgotten these rather inexpensive servos have, they only turn about 180 degrees, maybe even less than that. So in future iterations, I may also get a servo of approximately the same size, but somewhat higher price cost, so that I can have a servo that either has continuous rotation, so I can take in some of the slack, or at least turns the full 360 degrees. I also did add indentations for the breadboard here, and ideally what will happen also in later versions is that this wire will actually be not protrude quite as much. possibly just turn the whole servo around. I mean, it doesn't have to be this orientation. It's just easier for me when I'm building it. And here's the indentation for the Arduino Micro, which I was going by pictures of a Micro when I made it, and I had not realized that the Micro has not just the headers on one side, which you plug into for my application, but also headers on the opposite side in the middle. So this will require a larger hole um, in iteration 3 when I actually have something that can fit the Micro pretty well, and it's well toleranced for most of the dimensions. It just turns out there's headers on both sides, and in fact, the belt loop unfortunately was toleranced for the middle of belts, and I had neglected to realize that most belts, in fact, all belts that I've procured so far, have at least some amount of extra material on the end, which then does not pass through the belt loop. However, I did manage to take pictures using rope, and that proved well enough that at least the belt loop is strong enough to hold the entire tail up on what actually was dental floss. And by moving to an Arduino Micro, actually, I can make that right backwards compatible into the first iteration. You'll be seeing that during the demos. So that worked pretty well for the first iteration as well. And in fact, so that makes the first iteration all the more useful to me. Also, in the second iteration, the majority of the these tail rings here are now acrylic rather than 3D printed plastic. Makes it easier to produce them, and a 1/8. They're actually 1/8. The printed ones were about 1/8 of an inch thick. You can see here's one of them, and here's an acrylic one, approximately the same thickness. Didn't matter; it was a bit extra more thick, so that worked out quite well for making it a bit quicker. In future, I would like to try to laser cut more parts if possible. I have seen designs in which you laser cut multiple, say, layers of these and just glue them together. Or possibly, I mean, obviously, if I were to be doing some manufacturing on this, it would probably be injection or rotation molding, some much more effective process than 3D printing. But for the purposes of doing multiple iterations, 3D printing does go quite well. Of course, for the second iteration of this was done on a Cube Pro rather than the hand-tuned printer bot, and I was not necessarily all that thrilled with the Cube Pro. It was faster than the printer bot, but it seemed somewhat less precise, and I was not happy necessarily with the supports it produced. So I will hopefully be going back to the printer bot or something similar for the next one. And once everything is printed, though, it's quite an easy thing to assemble. Just thread the holes. You see a lot of screws on this. You thread all of those holes, and you just screw it together. And there's silicone adhesive for each end of the tubing here to stick it to the ends of the support and wiring system. And there's some amount of adhesive hot glue here to hold the spring on, and hot glue for the wire on the main wheel. The rest of it is all done with screws. The servo itself is just the basic thing you find on Adafruit. I'm, as I said, probably for iteration 3 going to try to find something with continuous or 360-degree rotation, just because it's not a very precise process yet, doing the tension on the wires here, and by making the main wheel so much smaller, I sort of made that even more necessary to get the tension just right. So until I can find a better way of handling that, I'm going to probably go to a larger main wheel and better holding system here. And in the third iteration, I will also be, as I mentioned earlier, I was going to talk about this, I'm going to be probably adding a lot of enclosure elements, because these wheels, I mean, as I said, you just see, I mean, even on the first one, where the tension was somewhat better, the wire keeps escaping these wheels here, and the main pulley wheel to an extent, and making them deeper did not help that significantly. So I will be enclosing them, which means that also, one thing I neglected to mention earlier, that the main wheel here and this wheel have to be super glued together, because they're printed in two parts. You can almost sort of see the line inside of them. And if I make them partly enclosed, I might be able to print the whole thing without having to super glue them together because there'll be built-in supports around the outside. And here's version 1, just for reference. As you can see, the tension on it is a lot better. Partly to do with the larger main wheel, partly because I just don't know exactly what happened when I was building this. I tried to make adjustments on multiple occasions. It just kept getting looser and looser. I think maybe because I didn't use quite enough silicone adhesive, or actually no, I needed to use hot glue to hold the wires in at the top. I did that on this one maybe a bit better, although actually looking at it, I don't think I used hot glue at all, so it may just be that I didn't tension it quite well enough on this one for the much better tolerances required for a smaller main wheel. On this one, of course, I have better tensioning and a larger main wheel, so it turns a lot better. And as you'll see in the demo video that should be playing in a moment, or even while I'm talking about this now, you'll see that the muzzle sensors work quite well for making it go back and forth. And I mean, even just a basic swing back and forth in time looks quite natural. And once it's in a better enclosure, a furred enclosure like you have like on the first suits, it should look quite good. As you can see, I'm having a little difficulty here because it does escape the wheels very easy, this wire. And part of the program was also that and again you'll see this as the video goes on, that I set it so that if there was that one of the problems with the EMG sensors is they have a tendency to echo a lot. That is, that you put some bang into them with your muscle activation, and it just sort of stays activated. I think that's more of a problem with the muscle than the sensor than the muscle, because obviously the muscle can't stay activated for that long after it's finished. So I may look into other sensors, and in any case, what I do is I have it go into this neutral position if both muscles seem to be activated, and for the most part, it works quite well. More on the right leg than the left. That is my problem though, because actually I once saw a physician about that, and funny story, he said that my one of my legs, I think it was my left leg, is not got the same nerve impulses as the rest of my body. So funny problem there. This system doesn't quite work well. Doesn't work too well with me unless I do some very fine calibration, because activation signal on one side ain't the same as on the other. I've been working on a program to try to make fixes for that. In the next, in iteration 3 or 4, let's bring up a graphic about that. I'm going to try to have it so that the EMG sensors, rather than using this silver chloride glue, are stuck on just by compression shorts. So I'm using conductive fabric attached to the electrodes rather than silver chloride gel, which will then be not only reusable but place itself in the right location on the muscle every time, rather than the AgCl gelled contacts, which have to be reapplied and vary quite a lot from usage to usage. They have that issue in service robots. Um, Also, it may just go straight on to just using the conductive fabric, just using the stretch on it rather than EMG signals. I mean, you don't need the muscle activation. It knows when if it just stretches and causes conduction when it stretches, then you probably don't need the activation signals because it's walking. So I may move on to that. It's not quite as high tech, but if it gets the result, run to the nearest FurCon and buy My Own Tail.